So in this video, we're going to talk about comparing functions using inequalities mostly. And so to start off with, we're gonna just look at a little bit of some real world data here. So take a second and check out this graph. So this is the median earnings of a full-time year-round worker. This is from 2012. It may have been actually 2010 because it was from the census. But you'll notice this is the female median earnings and the male median earnings. This is what people talk about when they talk about the wage gap. So, like for example, in the year 2000, females, their median, so like the very middle of all the females, their middle earnings were about 3,000, maybe 36,000 or something like that. And for males, it was about 50,000. Or if we looked at the year 2010, it's about the same thing. If we looked at the year 1960, females are making about 23,000. Males are making about 37,000. So if we wanted to compare these, let's say this is the male function, so we could call it m of x, and this is a female function, we could call it f of x. If I wanted to compare those, you'll notice that the male function is always greater than the female function, and so I would say m of x is greater than f of x, and that exists for the entire period on this graph anyway, so from the 60s to 2010. So if I wanted to give it a domain, I could say from 1960 to 2010. Here's another representation of that, by the way, if you're interested, of the wage gap. Okay, take a look at, this is our data from the Ridgeland High School Honors Academy. I don't have the last couple years, but you'll notice the blue column is Ridgeland students, this is Georgia, and this is the entire globe. So we're doing pretty well. This is the percent of total AP students with scores 3 and above. So did you pass your AP test? In 2014, we had 57% get a 3 or above, but we're currently at 75% getting a 3 or above, which is awesome. So we might say, like if we said Ridgeland would be R of x, and we could call Georgia G of x, and then we could call global W for maybe world, I don't know, I'm just giving them names. We could say Ridgeland is greater than Georgia because our scores have been higher every single year from, again, that's from 2014 to 2018, so I want to specify on the domain from 2014 to, to 2018. We couldn't say that for the entire globe because they were higher than us right here, but we could at least say from 2015 to 2018, Ridgeland scores were greater than the global scores or something like that. So what you've been seeing here is just comparing functions using inequality signs, like are the numbers higher, are the numbers lower kind of thing. So I want to real quick refresh on interval notation versus set notation because you're going to need this. For example, set notation is just using inequality signs basically. Like if you wanted to say the number's less than 3, you would say any x value less than 3. Or if you wanted to say the numbers between 4 and 8.5, you would say any number that's bigger than 4 and less than 8.5. Also, it includes 4 and 8.5, so it could be equal to 4 or equal to 8.5. And so that's a way I could represent that interval. This is called set notation. You just use x to represent a generic number, and you use inequality signs. Interval notation is when you write it as an interval. So if I want the numbers from 4 to 8.5, I write 4 to 8.5, and you write a comma in between to represent the word 2. If it includes the endpoints, you do brackets. If it doesn't include the endpoints, or it's an infinity, you do parentheses. For the numbers less than 3, that would be from 3 down, and so we'd say from negative infinity to 3, not including the 3. So that's interval notation and set notation. They mean the same thing, just different ways of writing that. Okay, so keep that in mind. Let's go ahead and compare these two phone plans. These are very old. This is very old, back when you had to like pay for the number of texts that you sent, which thank goodness we don't do that anymore. But so plan A costs $20 each month, unlimited texts. So it's just a flat $20. We call that a constant function. It stays constant. It literally just equals 20. Plan B costs 10 cents per message you send or receive. So let's say you send 100 messages, you owe $10. Which plan would you want? I don't actually know how many texts I send. So we could say plan B starts off being better, right? Because if I only send 50 texts, I only have to pay $5. So plan B starts off being better, or less than plan A, but that's only until 200 texts. If you're gonna send more than 200 texts, you should get plan A. So plan B is only better on the interval where x is less than 200. Or if you wanna write it in interval notation, from 0 to 200 texts. These mean the same thing. You should probably say greater than 0, or equal to 0, I guess. If it's more than 200, so if x is greater than 200, or if it's from 200 to infinity texts, either way, those mean the same thing, then we would say plan A is better because it's less than plan B. All right, so here's how that might look in a slightly more mathematical setting. So like on a coordinate grid, we might have the function f of x, which is a line, and this function g of x is exponential, which tells me a couple things. First of all, I know it's not going to go below the asymptote, and I know it's going to increase more and more rapidly. Keep in mind, exponential functions are going to be quicker growth than linear functions. So for all values of x, I know that f of x is less than g of x, just because it's below g of x and it's never going to be above g of x. Or, for example, on this one, we've got h of x, which is a line, and k of x, which is this parabola here. I know the parabola is never going to go above its vertex, it's just going to keep going down forever. So in this case, h of x is above k of x, so it's greater than k of x. You may want to compare a few values, right? Like when x is 1, where are we at? H is up here, k is down here. Or when we're at -2, this is where h is, k would be way down here, so h is still bigger. Or when we're at 3, h is up here and k is here. So you can tell that h is bigger than k at any x value. That's what this means for all values of x. Sometimes they might flip-flop a bit. So on this one, we would say g starts off being greater. So g of x is greater than f of x at first, but that's only until the x value -1. So that's only from negative infinity to -1. Then f of x is greater than g of x because it's just above it. And that happens from -1 to 2. And then from 2 on, g of x is bigger again. So then g of x is bigger than f of x from 2 to infinity. Because that quadratic growth is going to be more and more rapid rather than this linear growth. So that's kind of the idea. You may have to graph them yourself. Feel free to use a graphing calculator or Desmos if you need that as well.